Okay, we're going to solve and graph inequalities with the absolute value. Now, Mr. Wallace goes through a lot of work where he shows you why this is the case. But let me show you something that's going to be a lot simpler. If you want to do all the work and figure out why this works this way, that's okay. And it's probably even a good thing. But let me show you a real simple thing to do. Okay, if there was an equal sign there, we would know that x is equal to 2 or x is equal to negative 2, right? If you put negative 2 in here, that would be fine, wouldn't it? And if you put positive 2 in there, that would be the same if that were an equal sign. So let's just write this out as if those are equal signs for right now. So we have x equals 2 and x equals negative 2. Now that makes sense. But we have an inequality going on here. So how do we convert this inequality to this? Well, you can look in the book, and Mr. Wallace goes through a lot of work to show you why that is the case, and you can do that, and I even suggest that you do that, but we're going to keep it real simple today. I'm going to show you that the arrows all point in the same direction. Look, all of the arrows are pointing to the left. Keep it that way. That being the case, let's graph this. Oh, that's very nice. We got blue today. And as you can see, we start with a circle at the 2. That is because it is not 2. It is not equal to 2. It's everything less than 2. And so just like the arrow says, we're going to move in that direction. Now let's start with the negative 2. Okay, we discussed this in the last lesson, that when we have a compound inequality, we separate it out. And if you look at that, x is less than 2. That's pretty simple to graph, like that, and we've already done that. But for the second half is negative 2 is less than x. Well, so why don't we put the x on the other side? And I've squeezed it in here. So x is greater than negative 2 instead of negative 2 is less than x. You can read it either way, but it always makes sense to start with the variable. And as a matter of fact, you don't even have to do this. You can just read this as x is greater than negative 2. But I like to get my arrows going in the right direction because that tells me which direction my graph is going in. I'm going to start at negative 2 and we're going to move to the right just like my inequality sign says. It's pointing to the right. We're going to start at negative 2 right here and we're going to move to the right. And we're going to graph the overlap. And there you go, just like that, with a circle on the negative 2 and a circle on the positive 2 and everything in between. And if you're a little confused as to why we're doing the overlap, well, let's check out some numbers. Does the absolute value of 0, is that less than 2? Yeah. Is the absolute value of 1 less than 2? Yeah. Is the absolute value of negative 1 less than 2? Yeah. Is the absolute value of 3, let's put a 3 in there, is 3 less than 2? No. Okay, so we didn't graph that. The absolute value of negative 3, well, the absolute value of negative 3 is 3. Is 3 less than 2? No? Okay. So the graph that we did is correct. Now let's see if it was pointing in the other direction. Okay, let's see what happens when the absolute value of x is greater than 2. Okay, you can see that we've essentially done the same thing. We have negative 2 is greater than x. X is greater than 2. And we have the arrows, we just brought it down the same way we did before, and the arrows are pointing in the same direction as our first arrow. When I say arrow, our inequality arrow. And by the way, most people don't call that an inequality arrow. I think I'm the only person in the world who does. But anyways, it helps me to look at those things because I know that is the direction I'm going to graph it. And that is the direction when I pull these things down, it's going to be pointed in the same direction. Okay, again, it is not equal to 2, and it is greater than 2, so it is everything greater than 2. And you don't even have to know all that. Just do your graph in the same direction as the inequality arrows. And then let's take the other one and let's flip this side around. By the way, we can do that again. Maybe we don't need to do that. X is greater than 2. Okay, that's how we graph that. And how are we going to graph that? Well, we're going to have to flip the X. And again, when we flip the equation so that we have the variable on the left-hand side, remember that arrow is pointing to X. And so it's got to keep pointing to X, meaning you're going to have to flip it or just keep it pointing to X, whichever way you want to look at that. And now that we have X on the left-hand side, we can graph that. And then let's bring that down onto our graph. Boy, doesn't that blue look a lot better than our last lesson? Anyways, if you have the inequality pointing to the left, then you have an and inequality. If it's pointing to the right, then you have an or inequality. So we don't need to overlap here. Everything that we graph is going to go down here. And if that's hard to remember, like I said, let's just make up some numbers and see if that works out. We didn't graph 0. 0 is greater than 2. That's not true, so I wouldn't graph that. 3 is greater than 2. Well, yeah, that's true. Negative 3 is greater than 2. Well, the absolute value of negative 3 would be 3. And 3 would be greater than 2. So that'd be true too. So that works out. And I like to play with numbers, kind of like to check my work because it gets confusing. What's supposed to overlap and what's not supposed to overlap. And if you do that, you'll stay out of trouble. Now let's try another problem. Okay, we solved problems like this before when we were doing equality problems in respects to the absolute value. So let's create two equations there. Okay, in our first equation, we're going to just treat everything in the absolute value as positive. So we're going to just bring it down the way it is. And that's going to be greater than or equal to 6. Or if we bring the absolute value out as a negative value, what would be negative? Well, we're going to reverse both of these signs. So our positive 4x is going to become negative 4x. And our negative 5 is going to become positive 5. That is, negative 5 is positive 5. And it's going to be greater than or equal to the same 6. Now, let's work this equation out. Yeah, we're going to get the units over to the right-hand side. And let's bring all that down. And 4x is greater than or equal to 11. So let's isolate that x. There you go. And we don't need that 4 over 4. So x is greater than or equal to 11/4, which is also 2 3/4. And let's work on the other equation. Let's bring over the 5. That's right, you get rid of a positive 5 with a negative 5 and bring all that down. Divide both sides by 4. And that will isolate the x except for the negative sign. So we're going to multiply both sides by -1. And when you do that, don't forget to flip the inequality sign. Okay, let's graph that first equation. Okay, x is greater than or equal to 11/4. And I said 11/4 was 2 3/4. So let's come over 1, 2, and not quite all the way to 3. It's about 3/4. You know, we don't have to be exact, but we have a dot there because it is equal to, it is greater than or equal to. So it could be 2 3/4. And you see the way the arrow is pointing? Keep it pointing that way. Now, our next equation is x is less than or equal to -1/4. And you can see that my equal dot is just on the other side of the 0, just on the negative side of the 0, and we're starting at -1/4, which is 1/4 of the way to -1. And you can see that our arrow is pointing in that direction, so guess what? This arrow is going to go off in that direction. And then let's bring that down to the graph. Boy, I really like that blue. It's real easy to see. And all that black in between is the area that we didn't graph. And so that's our solution. Now let's try another problem. Okay, that's the same type of problem, but we're going to do a couple of tricky things. Let's get that units over to the right-hand side of that equation. Bring all that down. And let me stop here. Maybe you've noticed that I'm putting these flags on my 1. And that's kind of a European thing, just like the cross through the 7 is kind of a European thing. It's becoming more prominent in America. You don't see too many flags on the 1, so that's kind of a salute to our European viewers. And it's also, guess what? You don't see any flags there on these absolute value bars, so that's a good way of telling an absolute value bar from a 1. And by the way, in Europe, they put bigger flags on those 1s to where they almost look like 7s, and Americans often mistake them for 7s, so I just put tiny little flags on there. But anyways, we're going to divide both sides by 3. And that will isolate the absolute value of x except for the negative. And of course, -12 over 3 is going to be -4. So we're going to multiply both sides by -1. And of course, don't forget to flip that inequality sign. And the absolute value of x is greater than or equal to 4, which is going to look like this. So -4 is greater than or equal to x, which is greater than or equal to 4. So let's graph that. And that'll look like that. And then let's take the other equation, which is this right here. -4 is greater than or equal to x, and let's flip that. So now x is less than or equal to -4, and we can graph that starting at -4 and moving off into that direction. Just like that, and bring that down onto the graph. And that is what that will look like. Now let's try two very special absolute value problems. Okay, both of these are taken from examples in the book. They get a little bit more involved with it, but it's all work that you've done before, so I didn't want to go through that again. But the upshot of it is, when all of this is done, up here, the absolute value, remember this is the absolute value. X is not the absolute value. Everything in here is the absolute value. When the absolute value is less than a negative number, you can't have that, okay? Absolute value is always positive, right? So you can't have a negative number. So if you see this, if the absolute value is less than a negative number, is empty set. And you can take my word for it, you can take the book's word for it, or you can play with some numbers yourself and try to insert something into X to where that would be true, and you won't be able to. So let's go to the second equation. Before we go to the second equation, both of these this is less than -2, and this is greater than -2. You might have noticed that the absolute value that we had was always greater than or equal to a positive number in our previous examples. Well, let's see what happens when we have negative numbers. You saw up here, that's when it's less than a negative number. Now when our absolute value is greater than a negative number, the solution is all real numbers. Remember that funny R that we had previously? And you can just write all real numbers, or you can write that funny R. And here, again, you can take my word for it, or you can play with some numbers, and you will not be able to find a number that you can insert for x to where this equation is not true. It will always be true. And so you can start at 0 and point an arrow on into infinity in the positive direction and an arrow into infinity on the negative direction. If they ask you to graph it, I'm not asking you to graph it. And but if you see that on the SAT or something like that, you'll know what that's all about. And that is all of our problems, and that is our chapter on inequality.